Hi, good morning, everyone. In case of any misunderstanding, the person who is listed as speaking in the program is not here today, so I was standing for him, and I'll talk about this data as a service, or DaaS for short. We actually presented this a few days ago at the IEEE RI conference, the International Cloud Computing Conference on Cloud Computing Research and Innovation. So it's about a pilot that IDA is currently running. It's a cloud-based federated platform to facilitate the discovery of private sector datasets. So in my presentation today, I will cover a little bit about what motivated this project, this pilot, the design and implementation considerations, and the deployment details. I also cover some of the other challenges that we identified in facilitating data consumption in the private sector, and the corresponding initiatives that we have taken to address them. Okay, so data is frequently described as the oil of the digital economy and is today used in a wide variety of applications. However, to use data users would of course first have to find them. Typically, when data users have an application in mind, they will know the nature of the data sets they want. For example, I want the information about the footfall of Suntec City, or want information about sentiments of a brand. But where such data sets can be obtained may not necessarily be very obvious to them, especially, say, you are a fresh grad who wants to be an application developer today. So this is normally not a major issue in the public and open sector space, where there are normally government and NGO centralized web portals to allow you to look for data sets. So for example, if you stay in Singapore, you will know about the data.gov.sg portal that serves out public sector data sets. However, the equivalent is not available for data sets from the private sector. So where data providers in the private sector now, they currently operate in quite a highly siloed environment. There are usually many data providers, big and small, serving particular sectors, and they don't usually talk to each other, and they have a regular set of clienteles. So data users seeking data but unfamiliar with the industry sector of interest have no straightforward way to find these people. So this leads me to the key motivation of the pilot. First, with increasing popularity of mashing up multiple data sets within a single application to derive insights, there's a corresponding need for data users to be able to more easily find these data sets from unfamiliar sources. Second, it will be impractical for these data users to constantly be kept up to date, especially with data sets being made available every day, new data sets being published every day. Third, we realize that the use of ubiquitous internet search engines might not be the best tool to look for data sets. They might help you find images, videos, web pages, but they are not really built for data sets in particular. And finally, the competitive nature of business imparts minimal benefits for data providers in the private sector to voluntarily work with each other. So there we see a part for the government to play. This pilot implementation is a proof of concept to explore the equivalent of data set discovery mechanism that is often used in the government, in the NGO sector, but we are doing it for the private sector. So moving on to the design considerations. We have to keep in mind that the scope of the pilot goes beyond just a technical exercise. The pilot's key aim is to study the business feasibility for long-term and continued use beyond the pilot. So as such, we need to take into account design considerations that would help increase the potential for take-up and sustained use by data providers, and also the ease of access and use by data users. So in addition to address the challenge of data discovery in the private sector, it's also an order of magnitude harder than what we do in data.gov.sg. In the government, there could be an executive mandate to say that all public agencies should release data to the public. But in the private sector, there is rarely, if not impossible, times that we can do this. So such compelling leverage are not available, which is why we need to think about a different strategy to address private sector data sets. So next, we look at the platform architecture. It initially appeared straightforward or intuitive to adopt the same centralized approach that the public sector or the government agencies use. However, the feedback that we received from potential participating data providers is that because they are concerned about putting data sets at a place that's not owned or run by them, so there could be some issues in control and assurance given to them. So although a centralized architecture might have its advantages, such as being less complex to implement, it is not, in our view, not going to work for the private sector. So the concept of a federated or peer-to-peer-like architecture was then explored, with the aim of allowing private sector data set providers to be able to still retain control over their metadata and their data sets. And the resulting architecture is what you see here. The DaaS platform, or DaaS platform, is also named the Federated Dataset Registry. As a federated platform, it is collectively made up of individual dataset registries, or DSRs, operated independently by each of the participating data providers. So, and all of them predominantly run this on the cloud, while each data provider maintain their own respective dataset catalog. The DSRs actually communicate at the back end in a peer-to-peer-like fashion to allow cross-provider dataset discovery. So this gives the data users a view of the combined dataset catalog across all participating data providers. Regardless of which data provider the dataset discovery was initiated from, they do not necessarily need to know about these other data providers to start with. So the resulting architecture eliminates the presence of single point of failure, and any of these DSRs can go offline without affecting the overall functionality of the entire platform. However, when it comes to implementation considerations, a true peer-to-peer-like architecture was avoided due to the need to provide sufficient quality of service. So in a true peer-to-peer-like setup, when we scale with the number of data providers taking part, there could be a compromise in response times. And with that, there could be user attrition as well. So we went with a hybrid model where, to avoid a single point of failure, we have this DaaS administrative portal, which looks like a single point, but then it's actually replicated on the cloud to provide redundancy. Each time a data provider onboard new data sets onto the DSR instance, a database at the DAP is updated in near real time. A complete view of the combined dataset catalog across all participating data providers is just maintained at the DAP. Whenever a data user initiates a dataset discovery request at any one of these DSRs, the DSR will talk to the DAP and then vice versa. Because of the availability of mature data portal offerings in this pilot, we decided to go with one that is both open source, well supported, and has a large and reputable user base. Avoiding proprietary software also lowers the barriers for take-up by potential participating data providers. So we chose CCAN. It is widely used by governments and NGOs worldwide, and but it does not, however, provide the full functionality for federation that we require. So its built-in capability for federation was limited, and it's actually primarily designed for use cases where CCAN instances to be federated were known beforehand. But in our case, we want it to be self-help, so we wouldn't know how many are going to sign up, and we want it to scale, and we don't know when they're going to sign up. So to overcome this limitation in terms of federation and communication, we actually developed a custom CCAN extension. So this would accompany each of the CCAN installation of each of the data provider. So we provide this custom extension on GitHub, and it provides the vanilla version of CCAN with additional functionalities particular to the pilot. And it also takes charge of communication at the back end with the DAP. So to get onboarded, new data providers simply needs to submit their API key for CCAN and also the URL via a self-help portal, and then they can be part of this federated network. Elaborating a little bit more on DAP was developed to serve two broad purposes. As a backend, as I explained earlier, maintaining communication with all DSR instances in the FDSR to support functionalities for the platform. And as a front end, it provides this self-help portal that I also talked a little bit about. It allows for data users to provide, in addition to getting data providers to onboard themselves, it also allows for data users to onboard, to provide reviews of participating data providers and datasets, and for application developers to submit applications that uses datasets on this platform. So the platform was launched in October last year at an IDEA event, and we currently have 70 datasets from 27 participating data providers on board, participating in the pilot. So this is the landing page of a DSR instance that's set up by IDEA. So if you are familiar with CCAN, you know that it's straightforward to use. Yes, it shows some popular text relating to datasets on this particular data provider. And we require for the look and feel of all these landing pages to be the same, so as to give the users a coherent experience. It is not necessary for data users to look for datasets of on this platform at this particular page. They can go to any one of the other landing pages. So remember the peer-to-peer like architecture that we have used. Regardless of which one you go to, the results returned would be the same. So this is a screenshot of a sample search results that we have now. There's a search filter that you can use to filter by data providers, formats, tags, or even the Singapore Standard Industrial Classification category, where data providers, when they onboard themselves, they can classify their business according to that categorization, so that it makes it easy for users to look for them. You can also find out more about a dataset of interest through the dataset details page. So this is an example of one of our participating data providers dataset from Elixir Technology. So it's about corporate information of companies because they are also a reseller of Accra dataset. So you can see there's the different logo is a clue to the user that they have navigated away from the original landing page that they were looking for datasets on. So besides addressing private sector dataset discovery in this pilot, the same pilot also identified 3 other key challenges common to data use. So first, it is the low adoption or the use of disparate APIs for dataset access. So many transactions, data transactions in the private sector are still chiefly driven by regular clientele who purchase dataset in bulk download or sometimes through CD-ROM. So you can imagine how this would be quite unfriendly for unfamiliar data users who are trying to, say, mesh together different kinds of datasets. Even when the APIs are available, their design are often disparate, so it varies from data providers to data providers. And an application developer may possibly need to master as many sets of APIs as the datasets that they are using. Second, with new datasets being made available constantly, and many of them touting similar offerings, a dilemma is often faced by data users in which data offering to go to. Often when sample datasets are not provided, the only avenue the data user has is to evaluate a dataset, could be to make an upfront purchase. So this is not very ideal because some of these datasets can be quite costly if any of you have ever bought them before. So third, consider the scenario where a format of a dataset is updated but not conveyed via proper versioning and change logs to the owners of services and applications that use these datasets. So but in doing so, in not informing them in a proper manner, it could actually break their services and applications. So we think that the same rigor in software versioning needs to be applied also to datasets and the datasets be treated as a proper product. And this is often not practiced for datasets though. So we thought that there's something that we could do to help with that. So relevant guidelines were actually produced in collaboration with experts from the industry. And these guidelines were encouraged for consideration and use by these data providers participating in the dataset, in the pilot. So first is this TR33. It's a technical reference for DAS API design and implementation that was developed and published under the auspices of Singapore IT Standards Committee. So this document contains guidelines and best practices on API provisioning for datasets. A soft approach to incorporate it as part of the DaaS pilot was taken. So each time new data providers onboard themselves onto the FDSR via the DAP, they are required to complete a TR33 checklist declaring their datasets adherence to its guidelines and best practices. So this checklist is available for perusal by the public on the DAP, and it is hoped that through this public feedback and review by the users, the data providers will be encouraged to improve their adherence to TR33 of their datasets. So next is the guidelines on data quality metrics that IDEA published in April last year. The objective of the DQM guidelines is to recommend a set of common metrics which is industry and domain agnostic for adoption by the data providers. The guidelines describe the methodology for deriving this set of metrics and recommend a set of tools that users could use. So in the DaaS pilot, participating data providers are encouraged to generate this DQM and include such information in the metadata of their datasets. In our pilot, the one that we're using is the open source. It's from Human Inference, and it's called Data Cleaner. This guideline has since been evolved into a technical reference, and if I'm not wrong, I think it was published this month, end of this month. I think maybe yesterday, can't remember. So finally, it's the guidelines of dataset versioning that was published earlier this year, February, with the help of an industry work group. The document discusses issues pertaining to dataset versioning that could be faced by data providers and also provides some guidelines for and best practices for adoption by these participating data providers. So they are encouraged to actually peruse this. You see that it's kind of a soft approach of encouraging them to use it because that it's quite hard to mandate such things. So through this pilot, we hope that there could be some take-up. So to wrap up, I have covered briefly our federated or peer-to-peer-like dataset discovery platform that's based on the customization of open source software, which allows for private sector dataset providers to increase the visibility of their datasets and be discovered by unfamiliar data users. The proof of concept of this pilot is demonstrated in a real-life pilot that is currently running until next year. We aspire for future improved versions of this DaaS platform to become the go-to platform, specifically for datasets. So you can imagine it as a search engine for datasets. In future iterations, after some of the feedbacks we have received, we also think and plan to include things like safe search filters, to filter datasets that have been certified versus non-certified, or to include the federation of other major CCAN implementations, such as the beta version of data.gov.sg that was recently just launched. So with that, I think that's the end of my presentation. Yeah, thank you.